All right. Okay. So today, trees. Oh, I do want to
Trees.
mention one thing. I don't know how I forgot this, but in almost cpp.arr, when I was comparing mutation to no mutation, um,
Yeah.
actually the word people use is actually declarative. That's one of the more important words actually. So you hear the contrast between declarative versus imperative.
Okay, okay. It makes sense.
Yeah, okay, sorry, I just wanted to say that. Okay, next we're gonna move on to trees. I'm gonna create a new thing called trees.arr.
Of
So
course.
we're gonna go back to Python for the time being. But
Yeah,
if you can, I do want you to practice C++ at your own time. But I want to
of
speed run through the remaining of the fundamentals.
of
So
course.
now we're going to go
You,
trees.
you have you have like fundamentals of trees in Sunrise, right?
Did I?
Like this is what I did, right?
Oh, yeah, I think you. Oh, yeah. Okay, you know what? Man. Oh, wait, you did it quite a bit actually.
Yeah,
No, you know, let's just use that file. I'm gonna delete trees.arr.
of course.
Okay. All right, we're moving to sunrise now. Um, so the thing about trees is, here's a theory question for you. Can you
Okay.
how do I say this? Anything that you could do with a list, can you do it with a tree?
Hmm. Yeah, I can, right?
What? Why?
Because we can always like make the whole like left branch empty or the right branch empty, it doesn't matter.
Yes, yeah. Theoretically, yes. A tree where only the left slash right branch is used is basically a list, right? It's a very tall tree.
Yeah,
There's a term for this. I forgot what it is. Typically, we don't like it when trees are like this because you lose the benefit of the tree.
yeah,
I think it's called a really unbalanced tree. It's like something like that.
really unbalanced tree.
Yeah. We'll talk more about this in the future as to why that's bad. But yeah, if
Okay,
your tree is basically a list, that's bad. That's not good. But we'll get to that.
of course.
So theoretically, it's yes. So what we can say is a tree is is strictly as powerful as a list,
Mm,
but typically more powerful. But you won't
yeah,
hear the word powerful. Um, you actually hear the word expressive. I don't know if you heard this. A tree
I
is
didn't
more expressive
express it.
than a list. So when we say it's more, you know how like when we write code, right, we're writing expressions. Expressions have answers. Have you heard of that?
Yeah,
Yeah. So it's the same idea that the more expressions you can write, the more
mm,
the more flexibility you have to express yourself, right?
okay,
So a tree, you have more ways to express yourself compared to a list.
okay,
And so you can do more interesting things. So to get a tree, sorry, excuse me. Okay, okay, my throat is good now. To get a tree, it's actually very simple, as you found out. Instead of just having a rest, you have two rests. Of course, you can
Y-
call it rest because there's two of them. In your case, you call it left and right. In theory, you can call them anything. You can call them A and B, X or
yeah,
Y. Left or right is a pretty good name. It's pretty standard because visually, a tree goes left or right, so that's why people like that name.
yeah,
Uh, Interesting thing is that you can also have, in theory, you can also have like three children, right? Like left, middle, or right.
okay,
In theory, you could also have a list of trees, right?
mm, yeah, I suppose.
Yeah, so you can have as many children as you like. So, for example, now we have two. We could have three children or four. With two, we call this. a binary tree. Well, when you hear the word bi, it means two. So it's like two-nary
Yeah,
tree,
yeah, makes sense.
right? So so in line 14, we could be more specific. We could call it binary tree. Is there a search and replace in this language?
Mm,
Ah, that's great. Just leave it as tree. It's fine.
okay.
Yeah. With three, I honestly forgot. I think we call it I think it's ternary. Let me check. Let me check. Yeah,
Makes sense.
ternary.
Yeah, makes sense.
So like trinary. That's also more as I think it's quaternary is next. But what's interesting is if you have a list of children, if you have a list of children rather than a fixed number, so this is combining our previous data definition, right? Previously we learned list. We can combine list and trees. We
Yeah,
have a node can have n children, and so we have an n-iterary tree. Okay,
yeah,
but we're gonna stick to two for now, and I think we're
okay.
gonna stick to two always because I think for competitive programming, you're not gonna know more than two, right?
Yeah, I think so.
But what you'll learn is that what we learn with two, with binary tree, can be applied to all the other trees.
Okay,
Everything that we have learned so far is building up to this point as to why that's possible.
okay.
Um, all right, so let's begin. So remember, all the trees we're dealing with now is specifically a binary tree. All right, just keep that in mind as you do this.
Yeah.
So let's see what you have done.
Uh,
Okay,
all of those things are in Polish, so if you want
is
me
it?
to translate something,
Uh,
yeah.
the name is in English, so I think that's fine.
Yeah, yeah, yeah. So,
Okay, let's see. So you have tree template. So let's look at your template. Wait, you do this a long time ago?
yeah, like
Okay.
some
Wow.
time ago, yeah.
Okay, yeah, well, you all right. So yeah, you have got a very good head start. Tree template looks great. Um, this is so we're probably gonna work with numbers for now. I don't think I'll work with other data types just because competitive programming. I think when they give you
Uh,
trees, it's trees of numbers, right?
yeah, yeah, most of the
Okay.
time, yeah.
Are there exceptions? Do they give you like trees of strings, for example?
I don't think so. Like,
Okay.
I didn't see any like problem like that in
Mm,
Polish Olympiad. But
mm.
by the way,
Okay.
I haven't done nothing in past like the past weekend. I
Oh, all
did
good.
did nothing. Yeah, I did nothing.
All good, all good. I'll give you more things to do to make up for it. Don't worry.
Yeah, no problem.
Okay, tree size makes sense. Another word you may hear for size is count. You might hear tree count as
Mm,
well.
okay.
Tree sum. Okay. Yeah. Max. Oh, this is just a helper. I think the library
It,
also
yeah,
there is a
it
nummax, I
it
think.
has a nummax, yeah, but
Oh, you know, okay.
I didn't know that back then. I
Okay.
didn't want to use like built-in functions, so
Okay. Tree height, zero. Oh yeah, tree height very standard. Using a max. Yeah, yeah.
yeah,
Nice. So yeah, it's like the same idea, right? With like
yeah,
it's like structural recursion, but instead of dealing with one child, you have two.
yeah,
Yeah, yeah. And how do we combine them? Here you use max. Just like with tree sum, we use plus only,
yeah,
right? Tree size, we ignore the value. We only work with like each node is like a one, right?
yeah,
So
yeah,
again, very very same ideas. And I guess that's why you decided to do tree, right? You're probably thinking, oh, all these things I'm doing with this, I can apply to trees.
yeah. That's why,
Tr-
yeah.
Yeah, tree contains.
This was,
Yeah.
yeah.
Another way to write tree contains is you can also do value double equals target or the else case. You see what I mean?
Mm. You can show me. You can
So
show.
yeah,
Okay, yeah, yeah. Okay, yeah, yeah.
okay, I'm just gonna revert. I'm just letting you know. It doesn't really
Yeah.
matter, but that one is more, it's like
Because
looks
yeah, yeah.
nicer.
Because yeah. Okay.
Uh,
I always use like if because things will get like more complicated unnecessary.
I see what
Yeah,
you mean. Yeah.
yeah.
Tree double. Okay. BST contains. What is BST?
Like binary tree that has only like okay, I have like definition in Polish
Okay.
uh, like here in 9145. I
Yep.
will translate it. Um, uh, uh, okay, I don't know how to write that, but it has like only values smaller than root on the left and bigger ones on the right.
Yep.
Yeah,
I will rephrase that a bit by saying that
yeah,
all values
yeah.
in the left subtree is strictly less than the current
You
value.
can yeah. Can you write
Yeah.
that down because
Yeah.
I think you have like more experience with English, so
Okay.
like
All
a
value
bit more. Yeah,
subtree is strictly less than the current value. Oh, I should say for a given node,
yeah,
and all values in the right subtree. Oh, subtree is a smaller tree in a tree.
yeah,
Yeah, that makes
yeah.
sense, right? Okay.
Makes sense. Yeah.
Is strictly greater than the current value. Um, you might hear people drop the word strictly if you want to consider uh if two of the same numbers can appear twice next to each other.
Mm.
So we might drop strictly. But yeah,
Uh,
like something
But
like this, right?
yeah.
Okay. Okay, so you talk about binary search tree. So what's interesting about this idea is that we have a constraint that isn't in the structure of the data definition, right?
Yeah,
Like if I give you a tree, you don't you have to read the numbers in it to know if it's a binary search tree or
yeah,
not. The structure
yeah.
doesn't tell you that. So that's a new idea. We have so this is the first time. Well, I guess you saw this last time, but I do you see this a lot in competitive programming?
Hmm.
Okay, well, it's all right. I think
I
we
don't.
will.
I think
You,
I
hmm,
didn't like have many problems like that. But
okay. I think when we talk about algorithms, we'll see more of this.
yeah,
For
I
now, okay,
think so.
I'll give you pure structures for now. VST insert. Oh wow, yeah, you really did a lot. VST min, yes, very good.
Yeah, and that is all. I did I did not like.
Spot, that's a lot. Dude, you popped off, man. Holy crap. Okay, I shall reward you with more problems. Let me.
Yeah, of course.
Okay, you did like half of the problems I prepared.
Uh, by the way, I can like send you on email the list of algorithms that we need for like second stage of Polish Olympiad.
Okay, they have a list.
They strictly don't, but I asked like a friend who has like been in
Uh,
the third stage, and so
okay.
he isn't a friend that like it's just some guy that I know on the internet, you know.
It's just
So
some guy, okay. It's like
yeah,
me. You
yeah,
know a lot of some guys on the internet.
yeah.
Okay. All right. For your next problem, I'll okay, this one's a classic one. So I'm on line 145, given
Okay.
a binary tree, inverted. Does inverted make sense?
Mm,
Or reverse it.
can you like show me on an example or something?
Okay, yeah.
Because
I don't want to give you an example because I want you to think of it yourself. I'll give you the definition. All
okay.
for every given node, each their left and right subtrees should be swapped. Does that make sense?
Hmm. Yeah. Yeah. Okay.
Okay. So I want to now it's my turn to ask you. Can you write some examples of this?
Uh, I think so.
Okay. Oh yeah, this is considered your test, so you can already start. So follow the design recipe, and
Okay.
the test is very important.
Oh, I didn't do that like long time ago, right? I didn't copy the template. Yeah.
Oh wow.
So
Yeah.
yeah, some time has passed, right?
Yeah.
Mm, okay. I can just do it like this. Okay. Where? Okay. What was the syntax that I used? Okay, it was the empty. Okay, okay, okay. Okay, three. Can I call it reverse or invert would be like
Oh, either way
more.
works.
Okay. So re what happened here? Okay. I selected multi-line, yeah.
Mhm.
Uh, of the of course, right? Uh, hmm. Okay. I can do that like reverse on my what they call it T complex.
It's T complex.
It's an example, right? Right? Yeah, I
Okay,
think.
yeah. All right.
Uh,
Oh, habit I want you to have, and so we didn't go over this together, but increase the complexity of your examples by one. So don't jump from like zero values to like
okay,
10 values, right? So start with just one
okay,
node first, and then go to two, work your way up gradually.
okay. So note of I don't know, uh, one and two leaf should be note of one and leaf and two, right? I
So
think
what's the data type of node? Like what does node take in?
value left and right, right?
Left and right, and what types are left and right?
Okay, my bad.
That's okay. So
Yeah.
okay, let's go to the examples at line 27. Oh, you already have one here. Okay. So
Okay, yeah, I did.
so a habit I want you to have is firstly, I prefer giving this more descriptive name. So like T1. I don't think that's a very good name. I know you're trying to say there's one node, right? But I would have called it T10.
Okay.
Okay. And let's say we have a T2 here. I'll just create this for you. A habit
Mm,
one I want you to have is when you create more complicated examples, says if you want to, I want you to reuse the small examples. I didn't
hmm.
enforce this last time, but
Okay.
I think it's time that we start doing this because this
Okay.
will make your life a lot easier.
Yeah.
The
Yeah, it does. Yeah.
idea here is that recursive data definitions calls for recursive examples. You can, of course, write the long way, but when you write it the long way, it's very unwieldy and what you will find is that when you break down your examples into smaller parts, you can test the smaller parts. So like here we have 312, right? We can test T2 and T1
Mm,
independently. And what you'll find is that the answers for those will help you with the answer for T312. Okay?
okay, makes sense.
Why does it? You will learn very soon why it does. And another thing I like to do is also like as when you're thinking about examples, right? Don't worry about the problem statement yet. So now as I'm doing this, I'm just going to do this 3, 2, 1. And again, this is not for the problem we're solving. This is just me thinking, oh, what are other ways I could create examples that are interesting?
Okay,
So I want you to practice this more before you even start working on problems, on functions. Think about the data definition and think of interesting examples of the data definition. So this is something we did not have with this. The idea that we can take two children and swap them. Of course, now you and I know that's relevant to a problem we're solving, but even before you heard of the problem, this is something you want to do.
okay,
Okay?
makes sense because like on in competitive programming we will like have so many edge cases, right?
Mhm.
So
Especially for
create,
you, right?
yeah,
Your competitive programming, the way yours work is that you have few problems, but you get a lot of time. This must mean that the
yeah,
problem is difficult, right? So
yeah,
it's good to spend the time just thinking of examples.
yeah,
Like do it without expectation for reward. Maybe your examples will tell you something, maybe they won't, but it's okay. It's an exploratory process, right?
yeah, it is.
Okay, let's not worry about the problem for now. Let's focus on examples. Can you create more interesting examples?
Hmm, okay, I think I can.
Okay,
Like, okay, I don't know how to call it. Okay, so
it's
we'll
okay.
make the name later, right?
Okay.
So I can just call it, I can just like, mm, I want to like make uh, okay, okay.
So instead of making a node inside a node, let's reuse an existing example.
Okay, okay.
So by doing this, you're forcing yourself to increase your examples in complexity by one, right?
Yeah, right. But
Yeah.
okay, okay, okay. Uh, we have created that. Hmm. But I wanted to like make a tree that is only one-sided.
Ah, sure. So what
So
does it take to do that?
like we can't like use okay, we need to have like uh
Wait, you say you can't use an existing example? Why not?
okay, we can like this, right?
Yeah, right?
Yeah,
Okay.
yeah. Mm,
Right, so just by thinking of this example, we have come up with a new property of trees, right? The idea of one-sided trees. Trees that are incredibly
yeah.
unbalanced. Okay, awesome.
Okay, can we just call it like this?
Oh, you're gonna have to
Uh
change your tests, right?
yeah, I think I
Yeah, your,
will.
your tests are gonna break. So again,
Mm,
let's not write a node inside a node, right? Let's reuse an existing example.
so okay, okay, sorry.
Hmm. All good?
So like this. Yeah,
Yes. So this looks a lot better, right?
yeah, it does.
Okay.
Makes
Another thing I want
sense.
to talk about is naming. So notice we have a naming scheme here where we reuse the values of the nodes.
Yeah,
But let's look at line 31, 312, and T111. Both
yeah,
of them follow the same naming schemes, but they're structurally very different, right? One's a
yeah,
completely one-sided tree, the other one's a pretty balanced tree.
yeah. How would you name
So,
it? So,
okay, so before I have an answer, it's my
okay.
preference, but let me ask you first, like, how would you, what would be a naming scheme that would work for you?
Huh. Yeah, I don't really know. I don't really
Okay.
know because
So, mhm.
yeah, we need to
So here's what I would
separate
do.
like yeah.
Oh, so go on. You say
No,
separate
no,
one?
no, no. Like we want to separate the left side from the right side in the name, right?
Yep.
But how to do that?
Okay. So I wouldn't think in terms of that. Um, try. How do I wanna say this? I'll give you some ideas. Hmm. So I'll give you one way to think about this. We'll so again, this is going to depend per person. So one way is to do this. So each you bind levels together, right? Do you see line
Yeah,
31,
I
32?
thought about this, yeah, but
But it's not going to
it's
work
kind of
for T11, right?
confusing. Yeah,
For unbalanced trees, this isn't going to work as well because we don't know where the the lower level is located, right?
yeah,
And what
yeah.
happens if you have like leaves between the nodes? So another way is to okay, let's go with T11. You do this. So you specify every level. Sorry, I think I made a mistake with the define 34 should be this. And any leaf is just an underscore L. So this becomes one. And no, that's not gonna work for this.
Okay.
I need to draw this out. Hold on. So it's one leaf, one leaf, and then leaf. So two levels. Three, six, seven, eight. But we ignore the last row because it's fully L. So this is a naming scheme that we could do. So I'm not saying that I recommend this, but this is a possibility. Okay. So the idea here
Okay.
is that you are you're drawing the full tree. You pretend all the nodes are there, but any node that doesn't exist, you just put L. And so
Mm,
someone reading this can construct this picture in their mind and they understand what tree you're referring to. Now it looks a bit long, right? So you can take some shortcuts, for example. Maybe you can say tree L to say it followed by tree leaves, right?
okay.
But maybe this test case is very specific. You can just use words and say like OS1. So maybe left leaning one to say like it's a tree that's left leaning only and that's a one all the way to the left, right?
Okay. Okay.
So what we're talking about here is how we name things so that we can use the names very effectively. And this is actually
Yeah.
not an easy problem. I give you some answers and it's gonna different people will like different things, but I think it's good to think about them. All right, so I'll leave it up to you as to how you want to name things.
Okay. Okay. We can like leave this like that right now
Well, I just realized the
because
left-leaning one, you might also want to specify the levels, like how many times is left-leaning.
uh
So like for example, you could do
we
like
can
3LL,
yeah, makes sense.
right? I would just put two L's, right, for
Okay.
left-leaning, and then if you have right-leaning, you can do 3RR, right?
Oh, okay.
It's also good to, if you're working with other people, it's good to comment what the naming convention is so other people know what they're reading. But since
Yeah.
it's just you and me, we can skip that.
Okay. I think
All right.
I must change. Yeah. Okay. So it is okay.
Are you fixing the
Yeah, yeah,
tests? Oh, okay.
yeah, I'm
Oh, we should use the find and replace. Ah, it's
what?
okay. Find and replace. I don't think this language has it, but some IDEs you
Oh
can
yeah,
right
yeah.
click.
Okay. Yeah, yeah. Replace, yeah, makes sense. Sorry. I didn't
Mhm.
know what you are talking about.
Oh,
Like
where is this
like
used though?
I always use it in like Visual Studio Code, but it doesn't work in this like
Yeah, they don't have it. That sucks.
we must like
Submit a
talk
pull request.
talk of yeah, pull request.
Yeah, I think they're pretty like I don't think I think it's a very small team working on this.
Yeah, yeah,
In
I
fact,
think
I think it's
so.
just like two guys.
Yeah.
Yeah.
So okay. So the reverse of what is else there? Like this is uh I name this. What did you name this? Okay. Is this enough case tests or
For all purposes, sure. Yeah, for all purposes.
okay.
Let's look at line 181. When we have
Uh,
a left leaning, does it just
y-
become
right leaning.
is it like right leaning for one level or right leaning for all levels?
Okay. Yeah. 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 Okay. Of course for uh all levels, yeah.
Okay.
Mm, okay, we can use like this uh what is your like naming? So I think this is what you would call that.
I would actually call it 2RR underscore one.
Okay,
Yeah, that's
makes
how I would
sense.
call it. Yeah.
Okay.
So in theory, line 34 could also be changed to 2LL underscore one, but whatever.
Yeah. I don't want to change that in tests.
Yeah. Dude, I just
Uh,
realized it should technically be RL for right leaning, but screw it. I think RR makes
yeah,
more sense
uh,
in some ways. It's intuitive. I'll leave it up
yeah,
to you.
we can leave it. I don't want to
Okay. Right leaning.
write reading.
No, right reading, right? Instead of right leaning, you say right leaning.
Okay.
That's double R.
Mm, where is it? Okay, here. Okay.
Line
Uh,
185.
so it's one, right? Okay. We can finally write our function, I think.
Yeah, okay, let's do it.
Okay. So it should be leaf,
Hmm.
right? Uh, it, it should construct new tree, so node of value should stay the same. Uh, and we reverse on the right and reverse on the left.
Nice. Okay, let's run it. Oh, a bit of naming.
Yeah, because you changed it, right?
Yeah.
Yeah.
So can we fix that?
Yeah. I think I do. It's yeah. And to this uh what? Why is the empties unbound?
Is there a definition for TMT?
No, no, I okay, sorry. I just the
Oh, hyphen
I use
underscore.
hyphen and yeah, yeah, it's
Yeah.
T11 is unbound. Yeah, of course it is because you changed the
Oh
name,
yeah.
right?
Yep.
Uh, yeah, okay. It's we changed the names and I
No,
used
it's we changed that 10 to a 1 just now.
yeah, yeah.
So
Okay,
we
so
need to fix those tasks. Yeah, let's do that.
okay. Uh, are you changing it because I
Yeah, can you change them? Is there a way I can follow you in this file? Okay, you can, right? Focus participants.
how did you name this? It's not.
Sorry, which one?
Oh, okay. So
No, it's not a naming
y-
problem. It's
yeah,
the
yeah, we changed it to one. Like, yeah, yeah.
yeah, the T1 had a value of 10. Now it has a value of 1, right?
Mm, yeah. Oh man, I must change because I had like test to check if it contains uh 1 and 10, and I must like switch the booleans, right?
Yeah.
Uh, what is it a double? Okay, so it should be two, one. Mm, they missed something. Of course I did. Three double doesn't work because it's
Oh, this session is gonna expire. I'm gonna close this one and send you a new
yeah,
link at the
of course.
bottom of this file, okay? The bottom.
Okay, okay.
All right, I'll see you in a minute.
Uh, yeah,
Earlier, but it like
okay,
disappeared.
okay,
Okay, let's
okay.
continue.
I don't know why. Okay. I yeah,
Nice. All pass. Yeah, so thing about tree reverse is that usually when you like tell people this, they'll get like very confused, like, oh, how do I do this? It seems very difficult. But it's like just one line. See
yeah.
that?
It's very easy.
Yeah. All right, let's move on to the next problem. Let's see. Tree reverse. Ah, okay. Next one is tree flatten. Ask, design tree flatten, where the tree is squashed into a list and values maintain relative ordering. Does that make, sorry, excuse me, does that make sense?
Kinda.
Okay. All right.
Okay, okay.
Oh yeah, use the list definition in the language just so you don't have to worry about that.
Yeah, of course, of course. Uh, so okay. Template. Where is it? Hmm. 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 Okay. So like, okay, okay. We must write cases, right? Because
Yeah.
I like tests.
Hmm.
It will be easier to. Okay. Double T.
Yeah, double T. Yeah. It's generally
Okay.
true.
Okay. Mm, returning values, right? Uh, huh. Okay. Were our okay? So T1. Okay. Where was I? Reflatten of T1 is that was like this, right?
Hmm.
Reflatten of uh are we like doing it from like the most left side?
Can you show me an example?
So like this should be like list of uh 1, 3, and 2.
Uh, no. Okay, I'll
So
tell you
we
now. It's
should
3-1-2.
3 and 2.
Yeah, yeah. So like it's like the tree gets squashed from top to bottom. Does it make
Mm,
sense?
yeah, yeah.
Yeah, so the one's between 3 and 2, right? So that stays that way in the list.
Okay.
Yeah.
It's easier because I thought we okay, okay.
Oh, don't worry. We
It's
will be talking about the other ways to flatten the list in the future when we
okay.
talk about tree traversals.
Mm, I'm scared. Uh, okay. It's 1, 3, 2, right? Yeah.
No, it's 3-1-2.
Yeah. Yeah, it's the same as the name of the
So yeah, this
list.
naming scheme is very beneficial for you.
Mm, right. I suppose.
Wait a minute,
I
wait.
su
Oh, dude, so I brain farted. I'm so sorry. It's 1-3-2. It's 1-3-2. Sorry, sorry. Sorry, sorry. Wait, is it?
so
No, 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 sorry, sorry, it's 3-1-2. Bro, wait, hold on. Yeah, yeah, it's 1-3-2. Yeah, sorry.
you are like brainwashing me.
Sorry.
Like
Sorry, sorry.
gaslighting me.
Okay, wait, okay, no. Sorry, owe you a greater explanation now. So let me draw a diagram below. So we have like, so, yeah, sorry. What can I
Yeah.
type? Oh, okay, so it's sorry, it's three. It's this, right? So this
Yeah.
gets squashed from top down, so it's like this.
Yeah.
Okay, so sorry, yeah, sorry. Pretend I said nothing
So
just now. It's this. So it's one three
so
two.
1, 3, 2.
It's 1-3-2. Final answer. So sorry. I forgot my own naming scheme.
1, 3, 2. That
One three two. Final answer. Yeah. So this naming scheme is not beneficial for you. You have to do some thinking.
mm.
Yeah, yeah. Okay.
Thank you, man. Thank you.
Yeah, no problem.
We won't have like this problem with the like left heavy or right heavy side,
Let's
right?
see. Let's see. Hmm. So remember how we said like when all the branches, like when we're only using one branch of the entire tree, it's a list.
Yeah,
That's our list.
yeah, yeah.
It was so little thinking because the tree is essentially a list. Yeah.
Right, right. Okay. I think this is enough cases, okay?
Yeah. So I typically would want you to write like cases where there's holes in the middle of the tree,
Yeah,
but
okay,
it's
makes
fine. It's
sense.
okay.
Yeah.
Just cause for competitive programming, you don't need to know so much testing. I'll let you write the body now.
Mm, okay, so if it's live, it should be empty, right?
Leaf. Yeah, we call leaf, right? Not empty. Empty
Live.
is for list.
Yeah, empty is for list.
Oh yeah, yeah. It's cause we're making a list. Yes. Sorry, brain fart again.
Mm,
Yeah, nice.
okay. Uh, hmm. It should begin at the most left side. Ho, ho, ho. Hmm. Wait, what? Okay, this will be a list. If I return the left side first, it will... I must have a function that combines two lists.
Uh, there is one in the list library.
Uh, I have like created one,
Oh,
like in
okay. You're welcome
Sunset.
to use that as well. Yeah, either
In
works.
Sunset, I think. Uh,
Yeah, either works. You can either use the library function or you can use the one you created.
Combine lists, right? Yeah. Oh, fine. It works on num list.
Ah, so you're forced to use the library function then.
Uh, I read dogs.
Yes.
Lists. It's the like top search in my Google. Uh, please be like combine or something. Of course it isn't combine. Uh, do you know the name of it?
Okay,
Or
I'll tell you. It's a pen.
append?
Yeah, can you try
Yeah.
that?
Okay. I
So
I,
in
I just
most
I just I just found it.
okay, most languages will call it a pen. But in Python, a pen means to add one item.
Yeah, one item, right? Yeah. So
Yeah, but in this language, it's pen.
uh, mm, okay. Okay. So we need to like do this first on hmm, left, right?
Okay.
Okay. And oh, Okay, it makes sense, but can I do like this? Uh, hmm, not like this. I think it is ending of. Hmm. Will this work?
Let's see.
Yeah, it does. Okay.
Very nice. Cool. Yeah, it looks a bit like crap, but that's okay.
Thank you, thank you.
Yeah, no problem. All right. Okay, I think we have time for one more. We may not finish it. So I'll write a list of problems. If you have time, you can work on them. I'll give you a next one
Okay.
first. So the next one you will work on is tree map. I'm going to also write you some additional tasks as well. So tasks, design tree map. And I think from the name you can tell what it does, right?
Yeah.
So I'm also going to write additional problems. So if you have time to work on them, you could. Wait, have you started school yet or are you still on break?
No, I start school like in the beginning of like September, right?
Okay.
Like the
Let's-
1st of September is the beginning of school in
Wow,
Poland.
on the dot.
Yeah, yeah, yeah.
Okay. They're not messing around.
Yeah. Like not always if it's like comes like on Sunday or the weekend. Generally it's like the the first day after the weekend, right?
Hmm.
So in the best scenario, it can be on the 3rd of the September, right?
Hmm. So you can start by the way. Tree map.
Trim up.
Yeah.
Mm, mm. Okay, okay, uh, it shouldn't be hard, right?
Maybe.
Mm. Can I like avoid the tests for now because I want to do that quick?
Uh, sure, but I think to test you can just change. Yeah, okay, yeah,
Yeah,
fine, fine, yeah, yeah. So it's okay, yeah, you can just implement it straight
okay,
since it's abstraction anyway.
yeah. Uh, how to uh, like X to Y or something like that, and it creates mm, right. If it's a leaf, it still becomes leaf. Mm, and as it becomes a node of uh, an operation value, and then I didn't name it the tree map on left and operation, and, and then tree map on operation. Mm, that this it's I think. I will write the tests later. You are giving me a lot of tasks, and
Yeah, yeah, I'm just writing all
I
of them. You don't have to do all
yeah,
of them.
I probably won't have like any time tomorrow, but
Oh,
it's okay.
okay, yeah, we'll just leave this here then. Just don't have to write it down again.
Okay.
The tree map. Yeah, looks good. I think it's pretty obvious, right?
Yeah.
Okay. Before we end up, I have a theory question for you.
Yeah. Yeah.
Is it possible to make a tree filter?
Hmm. Okay, that is a that is a hard one.
Good. Okay, I want you to think about this.
Okay. Okay.
Um, and then we'll continue our discussion tomorrow.
Yeah.
All right,
Of
good work,
course.
Simon. Yeah, you made a crap ton of progress. I mean, to be fair, you did a lot of work in the past, but yeah, man, we just shot ahead really quick.
Yeah.
All right, good work, and I'll see you tomorrow. See you, Simon.
See you tomorrow. Yeah. Same hour.
Mhm.